today's lecture is part 5 of chapter 8, which is compaction and settlement. In the previous parts, we discussed what is meant by compaction, what is meant by settlement, different types of settlements, and so on. How to calculate the additional loads on the soil, how to calculate the settlement in the soil, and till we reached what is compaction. And today we are going to discuss what are the methods of compaction, how to compact the soil. A little bit descriptive what we are going to say. There is something called dynamic compaction. Dynamic compaction is something very easy to imagine. Just a very big weight, maybe something like a big footing carried by a heavy equipment, and this equipment will carry the load to a certain distance on top of the soil, and then it will leave it to fall down on the soil. Once it falls down, it compresses everything beneath it. I don't know, yes, this is what I wanted to show you. This is the equipment, this is the load. It carries the load and then leave it to drop freely to reach the ground. So once it reaches the ground, it compacts all of these craters, all of these circles on top of the earth. It depends, circle or square, depending on the shape of the footing. These are photos from sites, so they are existing. Once we finish this case, it means that all the points below these circles are compacted. So I just shift my equipment again and start compacting the points in between, and so on. The full site will be compacted. So this is called dynamic compaction. Of course, the dynamic force give me more effort to compact the soil. This shape needing it mainly refer to compaction of clayey soil. If I have clayey soil, then I need to have something with studs. These small pieces penetrating out of this equipment. Once it goes on top of the clay, these small pieces penetrate the clay. So once it penetrates the clay, it pushes the clay to the right and to the left and to the bottom. So it increases the compaction, because if you think of using just the normal roller in compaction, it will do nothing, because when I speak about clay, I mean clay with including water, clay with water. So imagine that if you imagine yourself standing on top of clay full of water, you will penetrate this clay. So you are actually compacting what is below you. But instead of standing directly on the clay, we put a very big piece of wood and you stand on top of it. What will happen to the clay? Nothing really, because your stress will be distributed on top of the clay and nothing will happen. So with this shape, these small studs help in penetrating the soil and forcing the clay to be compacted. So I need this shape in case I have clay and that this clay is submerged with water. There is another type, so this is a type, this is a dynamic compaction, this is one type. The third type is static compaction. It means that it should be similar to the compaction that we discussed in the first case, but it is static, it has no dynamic forces. What do I mean by static compaction? If I have, say, a sample like this, and this sample I put it in this equipment, it is surrounded from all sides, and on top of it there is a piston, and this piston is pushing the soil below. Once I push the soil below, with time or without time, it depends what type of soil I'm dealing with, but later the soil will be compacted. So whatever soil I put here, it will be compacted due to the effect of the static load coming from the top. So this is another type of compaction. Of course, this in lab, but I can apply the same on site. I will put load and will keep this load standing on the soil for a long time. Maybe this load would be something like embankment. I put an embankment on top of the soil. I put any load on top of the soil, so it will help in compacting the soil below. The fourth type is called vibrators. These vibrators are the normal roller that you see in any place. But most of the roller now, they add vibrating machines inside. So it's not just a roller passing on the soil, it is a roller with vibration. So it is moving in a circular way, and in the same time it is moving up and down, up and down. So each time this roller is passing on the ground, it is compacting the ground. Similar to this small one. Why do I need this small one, this handy type? If I need to compact a trench, a small trench, I'm going to lay a pipe, so I will just excavate a small trench, and I want to compact the bottom of this trench. I cannot let this equipment go inside. Maybe I have a trench of 50 centimeters. This equipment would be 2 to 3 meters. So I will need a small equipment like this. I can take this small equipment in very narrow areas and congested places. So this help. Of course, it is not as effective at this one, but it helps in places where this one cannot reach. Factors affecting compaction. What are the factors affecting compaction? Now we have seen different types of compaction, but what really causes the compaction? What increases, what gives you better efficiency for compaction? First thing, the type of the soil. Of course, if you are compacting clay, it's not like compacting sand. If you are compacting dry clay, not like compacting wet clay. This is something and this is something. This needs a method and this needs maybe completely different method. So type of soil is something very important. Water content, this is what I just said. The amount of water inside the sample or inside the soil affects the way I'm going to compact it. Never, if you remember in the previous lecture, we said that to compact a soil, we need to add water. You cannot just compact dry soil. I cannot just bring dry sand and try to compact it. It will be very difficult. So I have to add some water. Adding water will act as a lubricant. It will lubricate the particles of the soil so that they can move on top of each other to fit better between each other. So adding water is a way to lubricate the soil, and when you add more water, you compact better. So you start to compact better by adding water till you reach a certain value. Beyond this certain value, adding more water does not help you to compact better. Nevertheless, it compacts, it's worse. Why it is worse? Because you reach a condition where the water full or filled all the spaces, all the voids inside your soil. So adding more water means that you are adding water and increasing the spaces between the voids between particles. So you are really pushing particles away from each other. So at the beginning, water is coming, filling the gaps between points. I have just to show you a drawing. We'll go to the previous lecture. This shape. If I have, these are the particles, these are the voids, the white things, and the blue color refers to water. If I add more water, I will lubricate the particles more so I can compact better. Till I reach a condition that I have this shape, it is now compacted, and all this blue, white spaces turned into blue. It means that water filled all of the spaces. So what will happen later when I add more water? Water will go back here, push the particles again away from each other till I reach something like this, which is the original shape, but instead of having white color, I have all the white color changing into blue color. That's all. Water is increased. The amount of water has increased. So I have three cases. This is the first case, not yet compacted, and I still have voids, and I have some water. Then this is the compacted case. This is the optimum case. So this applies to this point where I still have less amount. This is the water content. This is a less amount of water content. And as I add water, the compaction increases. The compactions in terms of gamma dry, the unit weight of the soil. The unit weight, when the unit weight of the soil increases, it means that the soil is more compacted. So when I add water, the gamma dry increases till it reaches a certain point. This certain point is here, similar to this shape, but to this shape with water filling all of the spaces, all of the voids. Then once I start adding more water, then I will move on the curve in this direction. When I move with the curve in this direction, it means that particles are pushed away from each other, as if I am adding the water is acting as, instead of you compacting the soil, the water is decompacting the soil. It is pushing the particles away from each other, so it is not compacted. It is, again, you are removing the compaction from the soil. So this is the normal shape of a curve. This curve represents what will happen to the amount of compaction in case you add more water. So this chart helps you to understand what will happen. This is for a certain amount of compaction. Suppose I am compacting using this manual compactor. If I remove this manual compactor and I brought a heavy, big compactor, what will be the shape of my soil? It will be this one. So it means that when you increase the amount of energy you are giving to the soil, this chart, this full chart will be shifted to another chart on top of it. It means that the gamma dry will be more. With the same amount of water, you can get much compaction than before. So this is the case of having higher energy. What about the type of soil? If I have here cohesive soil, which is something like clay, and here is something like sand. Also, with clay, it is very difficult to compact. With sand, it is very easy to compact. So with the same amount of water and the same energy, you can reach higher compaction with sand than with clay. So these are the three things that you need to know: type of soil, water content, compaction energy. This is the effect of compaction energy. This is the effect of the type of soil. And the change in the curve itself is the effect of the water content. So here is the effect of water content, and here is the effect of water content. Now I need to check. I compacted. I told you now that this soil is now compacted. I've done my maximum effort, and now the soil is compacted. And you want to come to tell me, to confirm that the soil is compacted. How you are going to compact, to check this? You check this by doing something called field control tests. I should do a test on site to prove that the soil is compacted. What is this control test? So tests that are performed to determine the dry density and the water content of the soil after compaction. So I need just to draw a curve like this for the soil to know where am I for this soil. Suppose I discover that I'm here at this point. It means that I still need to compact more. Suppose I discover that I am at this point, then I will say that no, I am in the good compaction. Suppose you are here, I will tell you, use lots of water. You should have reduced this amount of water. Reduce it in further points. So how can I know where am I? Then I need to calculate my gamma dry and my water content. So I go to the lab, take a sample, calculate the gamma dry, calculate the water content, and check where am I on this curve. This is how you perform this test. You will check the sample size, you will check the weight of the sample, check the water content of the sample, check the density of the dry sample. These are what you are going to do. How to get the sample, you have or how to perform the test. Either you do a test called cone cutter test or sand cone test. What is a cone cutter test? Cone cutter test is something like this, a small tube like this. I push it to penetrate the soil. So I take from the soil a fixed volume, because whatever soil will go inside. Suppose I use this tube and pushed it in two soils, one compacted and one not compacted. Which tube will include higher weight of soil? The compacted or the loose? I have a fixed volume, and this volume I am pushing it into a compacted soil, and I'm pushing it into a loose soil. Of course, in the compacted, the amount of particles in a compacted soil will be high, so the gamma dry will be higher. So this is exactly what we do. Just push this tube into the soil, take a sample, take it to the lab, dry this sample. Once you dry this sample, measure the weight of the sample, so you know what is the gamma dry of this sample. Of course, you can calculate the water content also. How to calculate the water content? Measure the weight before drying the sample, and measure the weight after putting the sample into an oven. So you will get the difference in weight. So the difference will be the amount of water that has evaporated from the soil. So this is the first test, which is called the cone cutter test. This is how you perform the test and how you get the values using different equation. Suppose I want to know the gamma dry. Gamma dry is related to the gamma bulk, which is the gamma of the soil that I got, plus the water content that I have calculated. That's all. The second test is called the sand cone test. The sand cone test is just, of course, it is a test to calculate the density of the soil. To calculate the density of the soil, I will take some soil from this area. I will just dig a small hole and take the soil outside. When I take the soil outside, I can measure the weight. This is easy. I will put it on any balance and I will get the weight, but I cannot get the volume. The volume is different because I cannot know what was the degree of compaction of the soil here that was there, because I just got it outside. And I suppose you go to a field and you have some soil, sand and clay, and you dig a hole. When you take the material outside, is this material compacted the same as it was compacted in the soil? No, it changed. So I can get the volume, because the volume is the weight of the particles, and the particles is okay. But the weight. The weight is the weight of the particles, but the volume is the volume of the particles plus the voids, and the voids has changed because I disturbed the soil. The digging operation disturbed the soil, so I cannot get the volume. How to get the volume? I use this sand cone test. What is this sand cone test? I bring this apparatus with me. By the way, this apparatus, you will find it in your lab if you would like to go and check it. This apparatus, I fill it with sand that I know, say it is, I know exactly what is the properties of this sand. It is not similar to the soil that I don't know what it is. No, this is, this sand, I know it. I know what is the gamma bulk, gamma dry. I know the properties of this sand because I have already checked it in the lab. So what will happen is that I will open this and I will leave sand to come and fill this. And once I leave sand to fill this space, I can calculate the volume of sand that left this jar to fill this plate, to fill this hole. Because I know the volume of the sand, and I can know the volume of this funnel. So I can just, the remaining will be the volume of sand that was used to fill the excavated hole. So if I know the volume, then if I know the weight, and this sand is standard, then I can calculate the volume of the sand because I know the properties of this sand, so I can calculate the volume of the sand. This volume of the sand will be the volume of the hole. So now I know from this test, I know the weight of the soil that I took outside, and I know the volume of the sand, which is the sand that I know, the sand I brought from the lab, and I know the volume of the sand that was enough to fill this space. So now I know the volume of the space, and I know the weight of the sand or the weight of the soil that was there. So I know the weight and the volume. Weight and volume mean that you can calculate the density of this material. So this is exactly what is the sand cone test. Of course, here this is the procedure, exactly what you are going to do step by step and how to. But what I want you to know is just the concept of this test is that I'm drilling a hole, taking the soil outside. I can measure the weight, but I cannot measure the volume. So I bring sand from outside, and I can calculate the volume of the sand that is enough to fill the space. So this volume will be the same volume of the hole, and it will be the same volume of my soil that I took outside. So for this soil that I took outside, I know the weight that was measured directly. I know the volume that was calculated indirectly. From both, I can calculate the unit weight. So this is the second type, which is the sand cone test. So either you do the sand cone test or you do the cone cutter test, and with both you can calculate the gamma of the soil, and this will be your the way that we can check this curve. If this is my curve of the soil, and I measured gamma dry, and I measured the water content from using these tests, I managed to get the gamma dry and with the water content. And suppose I found that I am here at this point. So if I am here at this point, it means that my soil is not compacted enough. I have to increase the compaction for this soil, and so on. If I have a point here, as I said before, I will tell you, no, you have to reduce the amount of water that you have been using. If I want suppose I got something here, it means that my effort was very low. I have to increase the weight so that my point will move vertically up to reach this, and so on. Yani there are many cases. This ends up our lecture for the compaction and settlement. Next time we are going to discuss the consolidation, and as we said, the difference between compaction and consolidation is that compaction deals with immediate settlement. I compact something, I need it to be to settle at once. But in case of having clay with full of water, which is full of water, settlement will not be directly. It will happen after a very long time. So I have to study something else called consolidation, which is the effect of adding load on top of soil, so expelling water outside and settling my material. This we will discuss next lecture, inshallah. Thank you, and see you next time.